So we're just starting on a new topic now. This is still P2, but this is topic number 4, and it's current electricity. And the first thing we're going to think about is electrical charges. So by the end of this little talk, you should know a little bit more about what happens when an object becomes electrically charged. I want you to think about what happens when insulating materials are rubbed together, and also what happens when charges are brung together. Now, we've all seen this thing before where you rub a balloon on your head and it makes your hair stand up and your hair sticks to it, and you can stick the balloon on the wall or on the ceiling. But what is it that's actually causing that attraction between the balloon and the other things? Okay, well, the answer is static electricity. Rubbing the balloon actually causes it to become electrically charged, and it's that charge that attracts it to the ceiling or your hair or whatever it is you're sticking it to. So in order to understand what we're talking about when we talk about electric charge, we first need to have a little recap on actually what atoms are made of. So there's a sort of standard picture of an atom that you're used to seeing. This is just a refresher really. You've got the nucleus in the middle, okay, and the nucleus is made up of two things. It's made up of protons and neutrons. Now, hopefully you'll remember that in the nucleus, the neutrons are neutral. They've got no charge at all, but the protons are positively charged. So remember, P for proton, P for positive. They've got a positive charge. They're in the nucleus, so that means that the nucleus has got an overall positive charge. So orbiting the nucleus, we have got the negatively charged electrons, okay? And in an atom, there's one electron for every proton that's in the middle. So that means you've got one negative charge for every positive charge, which means overall the atom is electrically neutral, okay? So just to give you an example, calcium, for example, has got 20 protons in its nucleus, so it's got 20 positive charges, which means it's also got, we can add to that, 20 negatively charged electrons going around the outside, and plus 20 plus minus 20 is going to give us a 0 charge overall. So all these electrons are negatively charged, the protons in the middle are positively charged, they cancel each other out, the atom is electrically neutral. But here's the thing, these electrons can be transferred away from atoms, and they can be transferred into atoms as well. Okay, so electrons can be transferred to and from the atoms, and if the atom gains an electron, what it's basically done is gained itself one extra negative charge, so the overall atom becomes negatively charged. If it loses one of its negatively charged electrons, it's therefore going to have more positively charged protons than it has negatively charged electrons. So overall, the atom is going to be positively charged. And any charged atom, whether it's a positively charged atom or a negatively charged atom, is an ion. You probably remember that from chemistry. Okay, so what does this mean for charging up our materials? So, like I say, what has this actually got to do with static? Well, the thing is, when you rub two different materials together, some of the materials will lose electrons, while some materials will gain electrons. So by rubbing an insulator together, it means that it can either gain or lose some electrons, which means it either gains or loses some negatively charged, and therefore the overall thing becomes charged. Okay, so you don't actually need to know the little bit I'm about to tell you now, so feel free to switch off for 2 seconds, okay? But this is something called the triboelectric series, and this tells us whether or not something is likely to lose or gain electrons. So, these things up here at the top, we've got stuff like air, your body, human body, glass, nylon, things like that. If you rub them together with another insulator, they're most likely to lose their electrons. Okay, so if they lose an electron, what's going to happen is they're going to get positively charged, and as we go further down the list, they're less likely to lose electrons until we get down the bottom to these things down here, like polyethylene, urethane, vinyl, these plastics down the bottom. They're most likely to gain electrons. Okay, so these ones down the bottom here are going to gain electrons, and of course that means if they've got an extra negative charge, they're going to become negatively charged. Okay, so this is the triboelectric series. It's not something you need to know, but I just thought it's handy for you to sort of understand a little bit about what I'm talking about when I talk about, you know, which things gain and which things lose electrons. So what does this actually mean in the real world? Well, let's give an example. If I've got a plastic rod, I'll draw a little rod on here, okay? So it's just a bit of plastic pipe, and it's a polyethylene bit of plastic pipe over here, polyethylene. And I'm just going to rub that piece of polyethylene with a normal duster that you would find in your house, which is obviously up here made of cotton, okay? So if I rub these two things together, if they start to come into contact, okay, if I rub them and there's the friction between them, they're coming into contact, what's going to happen is we can see that the cotton up here is most likely to lose electrons, and the polyethylene down the bottom there is most likely to gain electrons. So some of the electrons that are on this piece of cloth are going to get transferred over onto the polyethylene rod. So all of a sudden this is gaining more negatively charged electrons, and because this is losing electrons, this starts to become positively charged over here. So by rubbing the polyethylene rod with the cloth, electrons are transferred from the surface atoms on the cloth over here really. They're transferred from the surface atoms of the cloth onto the rod. So the rod's now got more negatively charged electrons. So it is what we call negatively charged. Okay, you've got a negatively charged rod there. The rod is negatively charged. Okay, the cloth, however, because it's lost a lot of electrons, it is now positively charged. Okay, so we've managed to charge up those two things by rubbing them together. As a result, the cloth has lost some electrons, it's positively charged, the rod has gained some electrons, so now it's negatively charged. Okay, you can see also that if you rub different things together, for example, if I rubbed a piece of steel together with a piece of acetate down there, you would see again that the acetate down here would gain some of the electrons from the steel, so the steel would become positively charged, the acetate would become negatively charged. Okay? And it's just important to know at this stage, just so you know, it's just the contact between the two materials that transfers that charge. Rubbing them together obviously just increases the amount of surface area that comes in contact with each other. So rubbing them together really, it's just increasing the contact between them. Rubbing them harder wouldn't make any difference. People always think, oh, give it a harder rub, that's going to make it work better. No, it won't. It's just the contact between the two. Rubbing them harder won't make any difference at all. Okay? But the thing is, because these insulators, particularly these plastic insulators like this rod over here, are, they're good insulators, they won't let electricity flow through them. The charge that builds up, all these negative charges that build up on the rod, making it more and more negatively charged, the more you rub it, they can't flow through it. It's an insulator. So they're stuck where they are, and this is where the key word comes in. If something's stuck in one place, it's what we call static. Okay? Like a static caravan is a caravan with no wheels, it just stays in one place. Or static electricity is just electricity that is staying where it is. So we can investigate the charges that an object have picked up by seeing how they sort of affect each other, how they interact with each other. If I've got two balloons like this, okay, it's supposed to be a balloon, and no, it's not very good, but you get the gist. Two balloons like that. Now, rubber's down at the bottom end of the triboelectric series, so it's more likely to become negatively charged, okay? So if I rub it, on my hair, for example, my hair's going to lose some electrons, my balloon's going to get negatively charged because it picks up those electrons. My hair's obviously gone positive, okay? What do you think is going to happen if I put those two balloons next to each other? Did you just say something out loud? Hopefully you did. But what you should have said was, well, we've got two charges that are like charges here, okay? So like charges are going to repel each other, just the same as if you get two norths of a magnet and try and put them next to each other. They'll repel each other. So like charges are going to repel each other apart, okay? That's what like charges do. And in that case that if you've got two like charges, if you get two objects, I don't know what these things are, just two bits of stuff, okay? This one's negatively charged, loads of negatively charged electrons. This one's lost its electrons, so it's positively charged, okay? They've got opposites charges, so if they're opposite, what's going to happen to them? What do opposite charges do, or what do opposite sides of a magnet do? They will attract each other, okay? So like charges repel, and opposite charges attract. So this picture just shows you that a little bit more tidily than my scrappy drawings. We've got two like charges here, two positive charges, one here, and they are repelling each other. We've got two like charges again, this time they're both negative charges, one here, that are repelling each other, but the opposite charges, one positive gets attracted to that one, the negative gets attracted to that one, so the opposites attract. Okay, and this is a useful bit of information because if you understand the way that these charges sort of act around each other, if you know how one object is charged, you can use that to investigate the charge of another object. So, for example, here's Matey Boy out playing with his balloon, and we know that rubber balloons, is going to be negatively charged. He's holding it down next to his table here. It's attracting all these little bits of paper flying up and sticking to it. They're all flying up off the table and sticking to it. So if they're attracting, these things must be the opposite charge. So all of these bits of paper down here must have a positive charge to them. Okay, so you can use your knowledge of charges to investigate the charge of unknown objects. So just to sum up, let's go back and look at the picture we looked at the very start of this little chat here. What do we know? Well, insulating materials, that's the things that won't let electricity flow out of them, become charged when they're rubbed together. So by rubbing the balloon on top of the woman's head over here, they're both going to become charged up. Why are they charged? It's because electrons are transferred between objects when they become charged. And we know because of that little series of things, the triboelectric series, that you don't really need to know about, but I told you anyway. Okay, the triboelectric series, the electrons are being transferred off the woman's hair onto the balloons, so the balloons are getting negatively charged. Because those electrons are being taken away from the woman's hair, it's leaving her with more positive charge in her hair. And we know that opposite charges attract. That's why her hair has been attracted out and sticking to them, because if they're both the same type of charge, the charges would be repelling each other if they were like charges. Okay, so finish your notes on this, go back to Edmodo, look at the question, see if you can get that answered ready for the lesson. Bye.